Okay, hello class, weekly update 6. Lots of comments, so we're gonna try to speed through them, won't keep you too long. Okay, so every week we got our early birds, folks that get in there and do the assignments, get started early. So I wanna thank Cameron and Clarissa this week noticing a couple issues with dates or page numbers on assignments. So I was able to correct that for the rest of you, you probably didn't see it. And also then we've got our night owls folks that submit closer to the deadline. And I really tried to stay up late this week so I would make sure I didn't miss anybody that was submitting right there at midnight and to make this video. So usually the video will try to have it ready Thursday morning. So if you're one of those early birds, watch the weekly update on Thursday and I'll have some advice for the assignments. Okay, a few other things I noticed from the surveys. Thank you folks that submitted that. It was optional. I appreciate the feedback. That there are still a few things y'all are fuzzy on. One thing is vectors, normal vectors to a plane. We are going to hit those in book 3.5. In fact, the title of that book, it's all about vectors, vector spaces, vector fields. So you'll see that plenty. So don't worry too much on that. We're going to come back. The other one was half spaces, and also something we'll see again in book 3.5. And vector fields were just briefly mentioned in the recent chapter. We're going to have a whole chapter in book 3.5 on those. So we'll come back for those. It's just kind of a preview now. But I did want to say something quickly about half spaces. So you actually know, you've seen half spaces before. Like if you think about a one-dimensional thing, a number line, at some point if I say x less than or equal to 1, that's dividing that number line, that space of all real numbers, into half. So everything on less than 1 and everything above 1. So half spaces were inequalities, like again, just on the real number line. But in two-dimensional space, we have x or y, the same thing. Like if you had, you learned about plotting linear inequalities probably in junior high or high school. So like x plus y less than or equal to 2, that's a line, and then we'll have everything less than. So it divides this infinite space in half. Everything to one side of the line, everything to the other. And so for us, we're doing half spaces in 3D, so we'll have a linear object like a plane, but it doesn't have to be linear. I mean, it could be anything nonlinear, but generally when we're talking about half spaces, we usually have these points, lines, or planes, so all linear objects. So like x plus y plus z less than or equal to 3, that is going to be a plane going through the 3 intercepts of 3, 3, and 3. So this tilted plane in the corner of a room, and everything below that. So 0, 0, 0 would satisfy that x plus y plus z less than or equal to 0, so that we would shade on this side. Just the same tricks that you used in R2 work. So pick a point. If it satisfies the equality, you shade below. Okay. Oh yeah, and then many of you mentioned, thank you for the surveys too. Got to see like this is a 4-credit class, so you should be spending, anywhere 8 to 12 hours a week. That's the allotment to schedule for a 4-credit class. So if you're doing that, you're doing great. If you're going beyond that, maybe it's time to start emailing and letting Chloe and I know, and we'll make strategies to make it more efficient. Some of you though, much less time because you're able to really rely on other background material, and that's great, or relying on the teammates. All this is marching us ready to get ready for that final exam. So all these assignments are just to get mastery and understanding so you'll be ready to ace this final exam. And doing it in a way that's fun. Normally, of course, this would be midterm time. And you're probably experiencing that in your other classes. So at the end of this module, this week's module, I put an optional midterm. You don't have to submit anything. You'll see answers are provided, but it's something that you should probably print out and just have ready to take a look. That there'll be questions very similar to that on the final exam. We'll talk about the final when we get closer, but just to show you there's some material in there in this week's module that is optional, but it's something you should take a look at some point. So this week also is a heavy week because we have optimization is kind of the pinnacle, and it was back in Calc 1, it's kind of here again. We're going to deal with optimization in chapter 4. We'll get back to integrals, but for now it's derivatives, which the pinnacle of that is optimization problems. And we're going to look at this from a couple different ways. You've already done local extrema, you're going to do global extrema, and then constraint optimization problems. And I just want to make a warning also that there are a couple Sunday due dates. So please take a look at that, text your teammates if they might have overlooked that. So you have some Sunday and some Wednesday. I tried to break it down so that because it is a heavier week, split some of those assignments into do Sunday and then do Wednesday. The next thing was the discussion this time about verifying a tech tool. There's some really neat answers. I liked I'll mention a few here. Christy talked about group checking with a group and looking at the input to CalPlot 3D and doing that through Zoom live so they could see who was entering things and how it made the changes. Keegan talked about a really neat way that she was checking work was she used the fundamental theorem of calculus, which is that derivatives and integrals are inverse operations. And so if she was trying to find a derivative, she got the answer, she would then ask for the integral and see if she got the function back. That was a clever use, I thought. Many of you mentioned multiple tech tools, like trying something, say, in Desmos and then CalPlot 3D and then Wolfram to verify your answers. This was Grant and Clarissa. A lot of folks talked about sort of the sanity check, or some people call this like the sniff test, like logic, using logic and visual ways to check. So Patrick, Christy, Grant, Griffin really talked about, well, does this even make sense when you get an answer out? Like that's the first thing. And I really liked Griffin's answer. He talks a lot about in physics and astrophysics astronomy classes that you have to do some calculations and you can kind of sort of blindly accept what it say Wolfram's spitting out on something, but his the one that was funny was he talks about if my calculations, the tech tool tells me like the star is 20 feet right outside my window, then something's wrong, right? Okay, oh, I forgot to say something about the assignments this week too. So you have also with the one that's due on Wednesday. So stuff's due Sunday, I think some global extreme stuff, and then optimization due on Wednesday, so a week away. There's one called an optimization part 1 where I want you to I don't want you to solve it with calculus. I want you to think about all the different ways you could solve it. And I want you to be curious and creative and have fun with that assignment. There's a time limit on it. It might say something like do this for 20 or 30 minutes and just follow that time limit. If you enjoy it and want to take more time, sure, go for it. I've also gotten a few emails from folks that have talked about how they enjoy like taking their homework with them to work, like when they have to work on something else, but it's sort of a mindless task that you're doing at work where you can be thinking about your calculus homework. And this is one of those, this optimization part 1 problem. I think you'll have fun taking it with you where you go this week. Also related to this week, you'll notice that there are many videos in there. I put some at the bottom that are longer and extensive, like some things that repeatedly I'm getting questions last semester and this semester. So I made a review on how to compute critical points and also a review on global extrema. And some of those, again, I might have worked just 3 problems, but it took an hour to do it, to go through all those. They're pretty extensive problems. So just a tip, you probably already know this, but those are in YouTube, and in YouTube you can go in and like maybe make 1.5 or 1.25 the rate that is sent to you. And so that'll make me speed up the talking. I kind of talk fast, but that might be a way to get through those videos. And then you can pause on the places where, oh, wait, what is she doing in that part of the global extrema? And then you can understand it. Okay, and then this week's assignments. So I also put some things in the samples and examples, check those out. Some of the ones I liked this week, it was neat to see all the different under the towel activities and you guys different towels. Christie's I liked, so check out Christie's. She had one where the regions were interesting because she found one, like I think she might have put 2 like tennis balls or something under something and had ties. So she found there were places where you could have global extreme that have ties, and her region was clearly marked with like a maybe it was a necklace that she had used on that one. Keegan's was really nice. She took pictures of her towel, her surface, and then put nice labels on with a software program of what were the max, min, and saddle points. Oh, and that reminds me an issue. So I saw this one a lot. Folks did the FIST and talked about these. Well, notice no problem that these are all local max, and some of them might, depending on the orientation of FIST, be a global. Like for me, this one looks like a global max. This is a local max. This global max is a local. But there was some confusion about these in between the knuckles, right? These little areas here. These are not min, right? These are actually saddle points because they are min in one direction, but they're max in the other. To make sure you're clear on the difference between a saddle point and a min, there seemed a bit of confusion, which came up again with the alien under the shirt. I liked Liam's answer there. I think I put that one in. He just talked about the discussion of which was harder to make, local mins or saddle points. He had a nice discussion. On the calculations, I put Christie's and Griffin's, and I think maybe Clarissa's and maybe Aaron's. Check the folder, samples and examples. One thing I liked about Christie's was she had really nice tables when you're doing the d-test, right? So like you need to get your f of xx, f of yy, f of xy, f of yx. She had a nice table that laid that all out. And then she computed her partials and kind of had arrows where one was going into the other to solve that system, f of x equals 0, f of y equals 0, finding the x and y. So she had these arrows that sort of directed which equations were going where. Griffin's beautiful work again, check his out, very nice, very detailed, thorough. And then the other one I liked was the activity with the watercolor men. So only a couple people did this, but I think Griffin really nailed what we were trying to do with this assignment. Maybe I'll go ahead and pull this up because I think I should share this. Share the screen. We'll go into our Google, our course content in OAKS. So in OAKS, we're in module 3, week 1. Okay, yeah, so here's all the folks I dumped in here. Yeah, Clarissa, Dana Mae, Aaron, Griffin's calculations. So Griffin's calculations, oh, yeah, here's his d-test. Yeah, calculations for Griffin's and Christie's. Please check those out, but that's actually not the one I wanted. I wanted to go to Griffin's activities. So in the activities here, there was this assignment with the watercolor men. So he took a piece of paper, scrunched it, and then unfolded it. We now have a surface, and he used coffee to drop that, and you can see the trails. Let me see if I can zoom in a bit. All right, so yes, you can see the trails that they made, and there's a question about paths and what connecting it to things from last chapter with do they actually go to the local men's? Do they take the steepest path? And he has a nice discussion here. And then the last thing I liked, excellent discussion, read through all that, was this, he kind of puts this in the idea of like a 3D printer or a laser scanner, where if you have a cube and there's object in there, there's 6 different sides of that cube. And so he does this beautiful drawing of what it would look like from these different faces. We're looking from the top, from the bottom. So on the top's kind of like remember that's our bird's eye view with the contours. You can slice them through. And just trying to think visually and dividing it into each segment. I thought that was a really neat discussion and how it applied to the paths that we're finding here in the drop. So please check that out. Excellent work. Thank you, Griffin. Thank you, Chrissy. Aaron, Dana Mae. And I think Keegan's. Oh yeah, I like Keegan as well as in there. Yeah, Mitchell. Okay, well, enjoy taking a look at these and have fun this week with optimization. And again, it's kind of the pinnacle. After this week, though, we'll kind of get back to our usual schedule of this one is a particularly heavy week. So please plan ahead and text your classmates and group mates and let them know that.